So I'll get stuck right in. A little bit about me. I have been working in cybersecurity for nearly 20 years. I am the Solutions Engineer and Director for Tynes, an automation intelligent workflow company. And I look after both the EMEA region and the APAC region for solutions engineers, or solutions consultants, sometimes they're called then as well. I have been involved in mentoring, coaching, and even won some awards in the last few years within my industry in the tech sector as well. So hopefully what I'm going to bring to the table today will be interesting to you. Something I do outside of work is that I run the Irish side of the WESIS, which is Women in Cybersecurity, UK and I affiliate, and have done now for 3 years, and in my 4th year of it now. And so I'm bringing a little bit of flavour of both that and then the technical aspect to this particular talk today. So let's get going. What I'm going to cover on the agenda today is really an overview of the AI security landscape. We're going to cover some of the emerging cybersecurity threats, governance frameworks, what is trustworthy AI, and then I'm going to go into the flavour of the women's side of it, talk about some of the women that are leading the charge on AI security, and then at the very end I'll do a little brief bit on your potential career pathways and next steps as to what you should do if you're looking for those specific career types then too. So hopefully I get to cover all bases, but make notes of your questions as you go. I'll be happy to take them then at the end. So I'll get straight in. AI security, why does it matter and why now? So AI isn't some futuristic concept that we're experimenting with in labs. As you already know, it's already here. It's embedded in the systems that we rely on every day. So when you book a doctor's appointment, when your bank approves a transaction, when government services process an application, AI is making decisions behind the scenes in all of these instances. It's efficient, it scales, it processes information faster than any human team could. But then here's where it gets interesting and potentially a little scary. So every time we embed AI deeper into critical infrastructure, we're creating new attack surfaces. So these aren't traditional vulnerabilities. The AI systems learn and adapt and make autonomous decisions. Attackers aren't just exploiting code anymore, they're exploiting the learning itself. They're targeting the data that trains the models, the algorithms that power them, and then even the prompts that we use to interact with them. So let's say we think about healthcare. AI systems are diagnosing patients, they're recommending treatments, they're managing drug doses, and in some hospitals, AI is analyzing medical imaging faster and more accurately than humans will, or than human radiologists specifically. But what happens if somebody poisons the training data? So suddenly your AI makes recommendations based on corrupted information. A misdiagnosis isn't just an inconvenience, it's a life-threatening issue. One compromised model can impact thousands of patients before anybody even realizes that something's wrong. And then in the finance sector, algorithms are trading billions per second. So they're making split-second decisions about market positions, risk exposure, fraud detection. So if somebody's manipulating that model, the economic impact could be catastrophic. So we're talking about market manipulation at scale, automated insider training, or cascading failures across financial systems because AI learned the wrong patterns. And it's not just in these critical sectors. So AI is in the supply chain management, it's hiring systems, criminal justice, informing sentences and parole decisions. Every application has real world consequences for real people. Everyone is vulnerable in ways that we're still figuring out. So here's the kicker. Traditional security approaches don't cut it anymore. Of course not. You can't just firewall your way out of it. AI security is fundamentally different because the attack surface isn't just infrastructure, it's the intelligence itself. So the model's behavior and its decision-making logic, the data that it's learning from, it's all attackable. So defending it requires a completely new mindset. We need frameworks that account for the probabilistic systems, not deterministic ones. We need testing methodologies that go beyond does it work and onto can it be fooled. We need governance structures that are balancing innovation with accountability. So critically, diverse perspectives, people who think differently. We want people who ask uncomfortable questions, people who challenge assumptions that the homogenous teams would take for granted. So that's why women's perspectives are so critical. We need people who've navigated systems that are not designed for them, to understand that edge cases aren't actually edge cases. They're real people with real needs, and this builds resilient systems. Now let's talk about the threats themselves. So we'll start off with two of the sneakiest and most insidious, which would be data poisoning and model manipulation. The data poisoning is fascinating in a really terrifying way. Imagine that you're training an AI model to detect fraud. So you feed it thousands, maybe millions of examples of legitimate and fraudulent transactions so that it learns the patterns. What makes fraud fraud? What signals should trigger an alert? So the model learns from historical data. It identifies correlations, it builds an internal logic, and this is all really great so far. But what if an attacker slips corrupted data into the training set? So not really obviously malicious data, because that'd get caught, but really subtle tweaks that teach the model the wrong patterns. So maybe they introduce examples where certain types of fraudulent transactions are labeled as legitimate. Or maybe they manipulate features so that the model learns to ignore red flags. Over time, the model is going to internalize these corrupted patterns, and then it learns to be blind to specific attack vectors. So here's what makes it so dangerous. The model performs well on tests. So it looks fine, accuracy metrics are solid, but it has a hidden bias baked in, a backdoor introduced through that training data. When the attacker exploits it in production, the model does exactly what it was trained to do, which is ignore the fraud. So this isn't theoretical, as much as it may sound that way. Researchers have shown that across image classifiers, language models, recommendation systems, all of them, we're seeing examples of it. So if you're training AI on publicly available data sets, which many organizations do because it's cost effective and it just makes sense, then you're certainly vulnerable. Someone could poison that data upstream long before you ever get to use it. So by the time you've trained and deployed that model, the damage is already done. Detecting it would mean auditing the entire training data set, understanding where every point came from and verifying its integrity, which for obvious reasons isn't something that most organizations can actually do. But even with the proprietary data, you're not safe. So insider threats are real. You've got a malicious employee, a compromised contractor, even a supply chain partner that maybe has access to your data pipeline. Any of them can introduce poisoned data. So if your ingestion process lacks robust validation and anomaly detection, you won't even know until it's too late. So now on the model manipulation side, this is where attackers go after the model itself in real time. These are adversarial attacks. They're exploiting how neural networks process information. So picture this, you've got an AI system that recognizes images. So maybe it's screening luggage at airports or diagnostic tools, analyzing scans, something like that. These systems are trained on millions of images and they're accurate, they're trusted. But if an attacker crafts an input that looks perfectly normal to a human, so let's say it's an X-ray that appears fine, or a photo of luggage that just seems innocuous, but to the AI it's chaos, because maybe they've added imperceptible noise, the tiny pixel level changes that humans can't see, but that completely fool the model. Suddenly, your scanner misses a weapon, or your diagnostic tool misses a tumor. Your autonomous vehicle misclassifies a stop sign and thinks it's a yield sign. The consequences range from annoying to catastrophic in this case. And it's not just images either. So we're seeing adversarial attacks against natural language models, where carefully crafted text causes wrong outputs or leaks sensitive information. So against voice recognition, where audio changes fool authentication. Against autonomous vehicles, where stickers or graffiti on road signs cause misclassification. This attack surfaces everywhere. So what keeps me up at night is that these attacks are getting easier. Tools are more accessible, open source libraries, reproducible research, even commercial adversarial testing services. The barrier to entry is dropping all the time, which means that there's even more potential attackers. And as we deploy AI into infrastructure, healthcare, defense, all those stakes skyrocket. We're not just protecting data anymore, we're protecting decisions, diagnoses, and safety critical operations. So what do? We need robust testing, so deliberately trying to fool our own models before the attackers do. Adversarial training, where we expose models to malicious inputs during training so they learn to be resilient. Or continuous monitoring, maybe in production, where we're watching for anomalous behavior, unexpected confidence scores, and performance drift. Most importantly, we need security professionals who can understand both the technical details, which is how these attacks work, and the strategic implications, which it means when critical systems can be fooled. But we'll keep going with two more critical threats, right? As AI becomes more integrated into enterprise systems, prompt injection and supply chain risks are also ones to be concerned about. So prompt injection is especially relevant when it comes to large language models. When you use tools like ChatGPT, Claude, or Gemini, you interact through prompts. So questions and instructions that the model follows based on its training. Really simple, really powerful, and really useful. But attackers can weaponize those prompts. They craft inputs that bypass safety controls and then make the model do things that it shouldn't. So let's picture a customer service chatbot that's connected to a customer database. It's meant to answer questions and fetch information, nice and simple. A crafted prompt can trick it into revealing sensitive data or running unauthorized actions or manipulating the back-end systems. So it's kind of like SQL injection, but for AI. So instead of injecting code, you're going to inject malicious instructions into the model's context, because LLMs are built to follow instructions. A clever prompt then can override built-in instructions. So we've seen public examples where people jailbreak LLMs and they bypass safety just by embedding instructions in seemingly normal questions. Things like ignore all previous instructions and do this instead. A very simple, normal statement, but we're seeing people expose LLMs using things like this, or even more subtle variants. And it works because the model thinks it's just following the latest instruction, which is what it's designed to do. In an enterprise, that's dangerous. So illegal research LLM processing contracts could be tricked into leaking client data or generating wrong legal guidance that somebody maybe relies on. Coding assistance with repo access, they could be nudged into adding vulnerabilities or leaking proprietary code. The vector is subtle, but the impact can be huge. Mitigations are evolving. Prompt and input filtering, sanitizing instructions, strict access controls on what the LLM can actually touch, and sandboxing to contain damage. But then this is an arms race. So attackers iterate, defenders respond, and the cycle continues. So now, supply chain risks, often a lot less flashy, but just as serious. Where does your model come from? Most organizations don't train from scratch. They pull pre-trained models from public repositories, and they fine-tune it, or they fine-tune open source models and use maybe third-party APIs and ML platforms. It's really efficient and it's really cost-effective, but it's often a big and invisible risk. So if a downloaded model is compromised, let's say a backdoor was added during training, it might behave normally in tests and it'll pass validation. But under a very specific trigger, like a pattern of input, a time, or a condition, it's going to start leaking data, making biased decisions, or executing attacker control behavior. So the same applies to your ML libraries and dependencies. So let's say Python packages, frameworks, utilities, those kind of things. If a popular library gets compromised, then thousands of AI deployments can be impacted all at once. We've seen this pattern with traditional software, with things like SolarWinds or Log4Shell, and AI stacks are even are at least as opaque, often even more so. So with classic software, you can inspect the source code and scan for known bugs, but with AI, the code is massive weight matrices that you can't realistically audit. And then there's training data and processes that might be hidden or undocumented. So you're trusting this black box. So even without malice, risk can creep in. Biased training data, memorized sensitive info, buggy training pipelines. Without transparency and provenance, you can't easily see or fix these. So what helps? So model provenance, know where your AI came from, who's trained it, on what data, and how. Rigorous vetting of external components, not just does it work, but is it secure and compliant. Continuous validation in production, monitor for drift, anomalies, odd outputs, and then of course, a healthy skepticism. Because AI is still a software and data built by humans with all the usual flaws that you would expect from humans. Any organization that takes it seriously is naturally going to be safer and more trusted. Those that don't are gambling with security, compliance, their reputation, all at a moment when AI is making increasingly making decisions that really shouldn't be left to chance. So we've covered specific attack types. Now I'm going to zoom out a little bit and talk about how attacker techniques are evolving, because it isn't just about what they're doing, it's about how they're trying to do it. So the first up is going to be anonymous AI-powered attacks, autonomous AI-powered attacks. This is the stuff of cybersecurity nightmares. So traditionally, attacks required human operators, so someone to write the exploit, launch it, and then adapt it if any defenses kicked in. But we're now seeing AI-powered attack tools that adapt in real time without human intervention. So they probe defenses, learn from failures, and optimize their approach on the fly. It's like playing chess against an opponent who learns your strategy mid-game and then adjusts instantly. These attacks scale in ways that we've never seen before. So one attacker with an AI-powered toolkit can launch coordinated adaptive attacks across thousands of targets simultaneously. And because the AI is learning, every failed attempt makes the next one even smarter. So we're not just defending against static exploits anymore, we're defending against intelligent, evolving adversaries. Then there's deep fakes and synthetic media. So I know you've all seen the viral videos where we have celebrities saying things that they've never said, or politicians in fabricated scenarios. It's really entertaining until you realize the security implications. So deep fakes aren't just for misinformation campaigns. They're being weaponized for social engineering. Imagine this. An attacker uses AI to clone your CEO's voice. They call your finance team. They sound exactly like the boss and authorize a fraudulent wire transfer. It's happened. Or they create a video call that looks like your vendor's account manager, requesting updated payment details. Your team has no reason to doubt it. The voice is right, the face is right, even the mannerisms match. And it's not just executives. Deepfakes can target anyone. So your identity, your voice, your likeness, all of it can be synthesized with enough training data. So most of that is publicly available on your social media. The barrier to entry is dropping fast. This fundamentally changes how we think about verification and trust. Then there's model theft, intellectual property extraction. So if you've spent millions developing a proprietary AI model that's super valuable, attackers know that. They use techniques to query your model repeatedly, and then they analyze the outputs and then reverse engineer the underlying logic. So essentially they're stealing your AI without ever actually accessing your servers. And then finally, there's privacy attacks. So AI models trained on sensitive data, they can inadvertently memorize and leak that data. Attackers use membership inference attacks to figure out if specific data was in the training set, or they model inversion attacks to reconstruct actual training examples. So if your model was trained on healthcare records or financial data or personal information, that's a compliance nightmare just waiting to happen. Okay, so enough doom and gloom. Let's talk solutions. Because while the threats are real and growing, we're not defenseless. We have frameworks, strategies, governance structures, and a growing set of best practices to help build AI systems that we can actually trust. And trust is key. Without it, AI won't be adopted at scale or deliver the value that it promises. So let's start with risk management frameworks. The good news is that we're not starting from scratch. So we've got organizations like NIST that have developed the AI risk management framework that helps teams identify, assess, and mitigate AI risks in a structured and repeatable way. It covers governance and accountability, technical robustness, fairness and bias, transparency, and explainability. What I love about the NIST AI RMF is its adaptability. So it's not a rigid checklist, no one likes that. It's flexible, and it's a framework that you can tailor to your industry, or to your risk appetite, or to your regulatory environment. So whether you're in healthcare, finance, manufacturing, government, whatever you're in, you can adapt it to suit. In Europe, the EU AI Act takes a regulatory approach. It classifies AI systems by risk level, and then it applies the requirements according to that. Minimal risk systems like AI-powered games get a light touch. Limited risk systems like chatbots must be transparent. High-risk systems like healthcare diagnostics, critical infrastructure, law enforcement, they all face stricter controls, risk assessments, human oversights, conformity checks, post-market monitoring, serious stuff. Regulation can kind of feel heavy-handed. A lot of people would say it's not fun, not me, especially for innovators. But the EU AI Act is also creating a baseline for trustworthy AI. So it establishes accountability, it codifies responsible AI in legal terms, and then it levels the playing field for everybody. So if you're already doing AI security well, regulation becomes a competitive advantage. You're already ahead of compliance instead of scrambling to catch up, which is where most companies find themselves, or people find themselves. So these frameworks, NIST, the EU AI Act, ISO standards, and then other sector guidelines, they all give us this common language. They move us from AI security is important to here's how we assess risk, here's our mitigation plan, here's how we prove compliance to auditors, regulators, and customers. That structure is crucial for executive buy-in. Leaders are going to respond to clear frameworks and accountability. But frameworks are just the start. They say what you're supposed to do. The next question is how you're supposed to do it. And that's where adversarial testing and red teaming come in. So this is where we deliberately try to break our own AI systems before any attackers do. We assemble teams, both internal and external, or mixed between both, whose job it is to think like adversaries. They're not there to make the model look good. They're there to make it fail. So they're to find weaknesses, they got to exploit vulnerabilities, they got to fool models, and bypass safety controls. This work is surprisingly creative. I know it might not sound like it, but it is. It's not ticking compliance boxes mainly. It's asking things like, what's the worst that could happen, and can we trigger that in a safe environment before it happens in production? When the red team successfully poison training data, or craft an adversarial input, or discover a prompt injection path, then you don't get defensive, you celebrate it because you found it before an attacker did, which means you can fix it. And it has to be continuous all the time. As models learn and adapt, as new data flows in, as threats evolve, red team tactics have to evolve too. So it takes dedicated people, time, and tooling, but the return on investment is huge. Every vulnerability that you catch internally is one less future headline. And then we have model validation and continuous monitoring. So validation happens before deployment. Does the model perform as expected? Are there unanticipated biases? How does it behave on edge cases? Does it fail gracefully? So you stress test it, you run those scenario tests, you check fairness across groups, and then you align it with your ethics and compliance requirements. But validation alone isn't enough. Once it's in production, those models interact then with real data, real users, real adversaries. So the behavior can drift, you can't anticipate everything. Data distributions can change. There's new patterns that emerge, there's accuracy that degrades. Attackers are going to probe for those weaknesses, and pre-deployment checks aren't going to catch all of them. That's why continuous monitoring is a non-negotiable when it comes to AI security. You're going to need real-time visibility into the performance in the wild. Is that model making unexpected decisions? Are confidence scores dropping? Are there errors or anomalies spiking? Are users flagging issues that testing may be missed? You're going to need automated alerts when something looks off, because by the time any human spots it manually, damage most likely will have already been done. This is where an ML ops, machine learning operations, becomes critical. So that's about managing AI in production. So you want to have the same rigor as traditional software. Version control for models, automated testing pipelines, safe deployment, monitoring observability, and then incident response plans. And it all needs to be part of the life cycle from day one, not a bolt-on after deployment. It needs to be thought of before you go live. That means involving security early in AI development. So you got to treat AI security as a shared responsibility across data scientists, engineers, security, compliance, ethics, all those different teams. Having the hard risk conversations before you ship, not after a breach, in the ideal world. And building a culture where security and innovation aren't seen as opposites, but they're seen as partners. Secure systems are more reliable, more trusted, more sustainable. They're going to win your customer confidence, they're going to avoid regulatory pain, and you're going to stay out of the news for all the wrong reasons. So I'm going to talk about something as well now that I'm genuinely passionate about, which is why the diversity part isn't just a nice to have in AI security. but it's a strategic imperative. So I'm going to be really blunt. Diverse teams spot a wider range of threats. When everyone in the room's got similar backgrounds or training or life experiences, you get a really narrow view of risk. You're going to focus on threats that you already know about, attack paths that you're already familiar with, use cases that mirror your own perspective. And that in itself is dangerous because attackers don't think like that. Not all of them, and users don't behave like you. So the edge case that breaks your system usually comes from perspectives that you've never considered. When you bring women into the conversation and include people from different cultural backgrounds, industries, and lived experiences, then you suddenly see completely different threat scenarios. Let's say if someone asks, what if AI is used in a domestic violence context? Or how does this impact people with disabilities? Or what happens in regions where there's poor connectivity? They aren't hypotheticals, they're real world use cases that homogenous teams regularly miss. So I've seen this firsthand. In security reviews, some of the sharpest insights come from that person without the classic cybersecurity CV, because they ask questions that nobody else thought to ask. They challenge the assumptions, and that's exactly where vulnerabilities like to hide. When we look at ethics and bias, we see that AI systems learn from data, and data reflects the world, with all of its biases and inequalities built in. So if you're not intentionally thinking about fairness, representation, and potential harm, you will absolutely build biased systems. Not might, will absolutely build it. Women, especially those who've experienced bias themselves, are often the first to notice when a facial recognition model fails on darker skin, when hiring algorithms sidelines women, or when a credit scoring model punishes marginalized communities. And they don't just spot it, they'll push for better data, fairness constraints, and transparency. So it's not just about the morality, although that matters. It's about building systems that work for everybody, that don't create legal exposure and don't torture brand when bias is exposed. Biased AI is also weak AI. It fails in predictable, exploitable ways. Finally, the inclusive design makes systems more resilient. So when you design with diverse users in mind from the start, then you automatically build in flexibility and robustness. You test for more scenarios, you plan for more realities, and your system degrades gracefully instead of collapsing altogether. If you contrast that with systems built for a narrow group, they work brilliantly right up until they don't. And then they fail hard, because no one ever imagined the unlikely scenario, which was actually somebody else's everyday reality. The bottom line here is that diversity isn't a checkbox. It's about building better security. It's about having the perspectives, the questions, the insights that make AI systems resilient in messy, complex real life. The stakes are too high, the systems are too critical, and the threats are too advanced to rely on just one type of thinker. So women aren't just entering AI security, they're leading it across research, policies, and engineering, and their work is actively shaping how we secure and govern intelligent systems. When we come to risk mythologies and governance, women are at the forefront of AI risk management. They're building the frameworks organizations now use to understand control AI risk. At IBM, for example, the Global AI Ethics Program and AI Ethics Board are co-led by Christina Montgomery, who's the Chief Privacy and Trust Officer, and Francesca Rossi, who's the Global AI Ethics Lead. They jointly develop tools like an AI risk atlas to help enterprises reason about model and generative AI risks. They sit exactly at that bridge between the deep technical issues like model robustness and data misuse, a non-technical audience such as boards, regulators, and customers who need clear, actionable language rather than math. Beyond the industry, women are also interrogating how AI risk frameworks intersect with power and inequality. So a feminist analysis of the EU AI Act, for instance, highlights where its current risk classifications still fall short on gender and structural bias, and recommends a more intersectional rights-preserving revisions. So work like this directly influences how AI risks are framed in regulation and in enterprise governance. And when it comes to adversarial testing and technical research, some of the most influential work on adversarial machine learning and AI security comes from women leading research labs. So Dawn Song in UC Berkeley has spent years warning about adversarial machine learning and demonstrating concrete attacks and defense techniques, including poisoning and prompt-like attacks on language models that led companies like Google to harden systems such as smart controls. Her work is the textbook example of someone red teaming models, discovering new attack vectors and then turning those findings into practical defenses that industries actually deploy. Then on the harm side, Joy Buolamwini, I've struggled with her surnames, gender shades project exposed massive racial and gender disparities in commercial facial analysis systems. So she's showing that models from major vendors performed far worse on darker skinned women than on lighter skinned men. And it wasn't just an academic result. It forced vendors and policymakers to rethink testing, auditing, and deployment standards for biometric AI, and it laid the groundwork for today's AI bias and fairness practices. When it comes to policy, standards, and regulation, AI regulation is being written right now, and women are central in turning the abstract responsible AI principles into concrete rules and standards. At IBM, Montgomery and Rossi have led the build out of internal governance and ethics structures that now serves as the reference point for external policy discussions. Outside of industry, women scholars and advocates are critiquing and shaping the EU AI Act through lenses like gender and civil rights, helping legislators understand where the Act adequately addresses discrimination, and of course where it doesn't go far enough. Raman Chowdhury is another strong example. So she led responsible AI at Accenture. She founded the algorithmic auditing startup Parity and then ran Twitter's Meta team, which is the machine learning ethics, transparency and accountability team, where she built the internal audit and documentation processes for models deployed at platform scale. Her work sits exactly at the intersection of technical machine learning, risk and regulatory expectations, so many organizations are now struggling to navigate. Women are also hands-on keyboard building the infrastructure that makes secure AI deployment impossible in production. Many of the women in IBM, Deloitte and others spotlight as AI leaders are not only in ethics policy, but also in roles leading the ML engineering, cloud security and trustworthy AI tooling. They're designing zero trust-like architectures, so they're securing MLOps pipelines and monitoring systems that detect drift and adversarial behavior. They're in sectors like healthcare and finance, where women leaders are building AI diagnostic and fraud detection systems that explicitly balance accuracy, privacy, and fairness, and not just raw performance. And why this matters to you, they're not isolated token examples. IBM alone has publicly highlighted dozens of women globally who are shaping AI governance and ethics and security. Universities, think tanks, and advocacy groups are now routinely featuring women as lead voices on AI bias, adversarial ML, and regulation. And every one of them started where you are right now, maybe without a perfect CV, but with the decision to step into the work, learn in public, and lead anyway. So let's get really specific then. Where are women actually making an impact in AI security? So on the technical leadership side, when you're deep in the weeds, hands-on with systems. In security architecture, you design AI systems. You design how AI systems are built, where they sit in the network, how they're isolated and protected, deciding on encryptions, access control, data flows, model deployment patterns. This blend of cybersecurity and AI literacy is exactly what leaders like Dawn Song at UC Berkeley are known for, combining that formal security methods with AI and agent safety research. In threat modeling, where you think like an attacker, mapping vulnerabilities, identifying attack paths, women leading red teaming and adversarial research in big tech and academia, for example, many of the ones I mentioned from IBM and Deloitte in AI safety and robustness, are doing precisely this. They're formalizing new threat models for AI systems. In incident response, senior women in cybersecurity like Teresa Payton and other incident leaders are now tackling AI-driven threats. They're steering these responses where Gen AI and classic security collide. All these technical roles make you the person that ensures AI systems are secure from the ground up, that threats are anticipated, and that when breaches happen, they're handled intelligently, not reactively. We badly need more people who bring those different perspectives and are willing to challenge assumptions. And then, of course, there's strategic roles. So in policy, you partner with legal and compliance to align with GDPR or other EU AI Acts. People like Roman Chowdhury, who led responsible AI at Accenture and Twitter, is driving auditing and regulatory thinking through parity AI. Compliance work makes it auditable. There's documentation, evidence, control testing, all those things that prove systems meet the required standards. Many women in the Women in AI programs at firms like Deloitte now sit in these roles. They're sitting between regulators, auditors, and engineering teams that turn the high-level rules into actual operational reality. And then ethical frameworks, where we have people like Joy through the Algorithmic Justice League have shown how servicing and challenging bias in deployed AI systems changes corporate behavior and forces accountability. But let's talk about you. There's a couple of roles that I want to just specifically call out here. We'll talk about, first up, AI security analyst and researcher's role. If you like digging into how things work, finding vulnerabilities and solving puzzles, this is your lane. If you like on the AI governance and compliance specialist roles, if you love structure, process, accountability, this is where you're likely to shine. Governance specialists design the framework that designs how AI is developed and deployed. And compliance specialists make sure systems meet regulations and standards like GDPR and the EU AI Act. Then there's the machine learning security engineer path, where security meets engineering. So you're going to build those secure ML pipelines, implement adversarial defenses, and harden the models against attack. That might mean secure data ingestion, training in trusted environments, robust deployment patterns, monitoring for anomalies. It's technical, it's coding. And then finally, the leadership roles that are shaping AI strategy. So things like Chief AI Security Officer, Head of AI Governance, AI Ethics Lead, and similar. Those are emerging as organizations realize AI risk needs dedicated leadership. So you don't go straight into those titles. They require experience and a track record, but because the field is young, the pipeline is wide open right now. If you start now and build expertise and show up through things like talks, writing, mentoring, leading projects, stuff like that, then you can get to those senior roles faster than in more mature domains. And organizations are actively looking for diverse leaders. Homogeneous leadership itself is now seen as a risk. So how do you start? Build foundations. If you're strong in security, add AI. If you're strong in AI, add security. Get hands-on, contribute to open source, join AI security, capture the flags, build mini projects, share what you learn, blog posts, talks, GitHub. Then network, join communities like WESIS, we have the Women in Cybersecurity, ISC2 chapters, AI security meetups, online groups, go to conferences, whether they're virtual or in person, ask questions, be visible. Find mentors. Reach out to women or others that are already doing the work. Many will happily share their time and open the doors. And then be bold. Apply even if you don't tick every box. Speak even if you feel like an imposter. You have value now, not just someday. So the path into AI cybersecurity isn't a linear path. It's really messy. It's evolving. It absolutely has room for you. The real question isn't, am I perfectly qualified? It is, am I willing to start and keep going? And if the answer is yes, then the field genuinely needs you. And that is me. Thank you so much for the time today. And if any of you have any questions, then I'm happy to take them. That's a really good question. I think on the fuzzy logic side of things, there's not enough people talking about it or getting involved in it first. So it's used kind of at the anticipation layer. So I'd say to move from the reaction detection into foresight, you have to explicitly model like three things. So uncertainty, progression, attacker intent, and define those variables. I think the answer for this is probably just as long as the question, in fairness. There's very specific things that you can do, but if you're creating these large language models and not thinking about it already, that is a concern to begin with. What I can do, if you want to ping me on LinkedIn, and I'll get into the much more specifics about what you can do specifically to get it in and be heard as well too, because I think there's a lot to that answer. You're always at the forefront of it in anticipation and forecasting, as opposed to on the detection side of things. Is that fair? So when you're talking about the OWASP, and usually the top 10 people are focusing on from there, all of those vulnerabilities give you information on how they're exposed and how to not just find them, but how to exploit them as well. So traditionally, that was through things like the CVE. I'm trying to think, it was the NVD, sorry, the National Vulnerability Database would have all of the CVE information, and within it would have information from the vendors on how to exploit those vulnerabilities. So if that's what you want to do, obviously it would be done in a test site and not in a live site, but the information you need on how to do it will be offered by the vendor in how to fix it. So in order to know how to fix something, you need to know how it's broken. So you can get that information typically, if not from the CVE sites where you'll find the vulnerabilities detailed, you'll get it from the vendors directly. So for example, when it comes to something on the Microsoft side of things, they'll always publish what it is, and then in the information that they're publishing, it tells you how to exploit it. Probably not in a how-to, because they don't want to produce it that way, but it's easy enough to see how it's done from there. That's the best way to find out how to do it. Now, if it's something that you're practicing or you want to see if you can test and exploit, for obvious reasons, that should be in a in a sandbox environment, not in a live environment, if you know you have that vulnerability. So there's stages to this, like identify that you have the vulnerability, and you could attempt to exploit it if you're not sure, but it would be a high risk thing to do with regards to any live environment. You'd want to be doing it on a sandbox environment and then patch your vulnerability or do whatever you need to do to remediate your vulnerability from there. If it's something that you want to do for the fun of it, you just want to see how it works to exploit a vulnerability, then create a sandbox environment with that exposure in it, and test it there. Or as somebody who's on the red teaming side of things, it might be a case that you will identify that it exists. Ideally, don't expose it because of the impact you can have. It's a funny one. How do we tell them to act when they're telling us how they act? The biggest missing piece in early AI governance setup was the humans as such. Like, it's easy enough to identify data and technological output and then create governance based on that. If you look at things like CIS compliance for devices, it's easy to export the configuration of a device, then go through and identify what needs to be done better and create a list of compliance requirements based on something like that. It's all very tick box. But when it comes to the AI side of things, you're right, AI is making a lot of decisions, but you need to introduce the human into more aspects then. So you're always trying to think about what could happen next. If we talk about hallucination on the AI side of things, like how do you reduce the volume of hallucinating that your AI does? At what point do you refuse its ability to make decisions on things? Where do you have the human in the loop that's going to actually sign off on what AI is suggesting be done? That's really where it's more important when it comes to the AI regulations. It's less about the configuration and what you let the AI technically do. It's more about what you as a human choose to, how much control you would choose to give AI. So human in the loop is the most important thing. I think, this is obviously my opinion, I'm not writing the compliance or the standards, but where the biggest risk is at is where we take humans out of the loop. There's any number of stories that you could read and easily Google and find out where companies have let human resources go to replace them with AI, only to backtrack and put the human resources back in, because in allowing AI do all of the things without any human in the loop interacting with it and validating everything that's to be done, it has caused a significant negative impact for that company and certainly for any consumers of whatever that company does. So for me, that's the difference when it comes to the governance framework as such, is to always consider the human as the risk, as the victim as such in any attack, and then as the implementator. Somebody has to take responsibility. So if you're allowing your AI to make a decision that you wouldn't stand by, then you're allowing it to make too many decisions. It's a real rock and a hard place question, in fairness, because to be fair to whoever submitted that in, we've gone so far down the road already with AI without stopping to considering the bias that's already built into it, that now we're backtracking to try and remove the bias. because all of these large language models, or at least the majority of them, are all built on existing data which has bias in place, and then it's hard to use AI to clean that up if AI is already biased. So yes, it is a challenge. What we have is there are entities and there are groups of people like the Women in AI side of things that are advocating not only for the change going forward, but that are working with people building large language models and people that are involved in machine learning on sort of starting from scratch with clean data. So companies can choose the data they use, whether they use the publicly available data structures that are already in place, knowing that there is bias built into those, whether we like it or not, or whether they build from scratch. So if a company is particularly concerned about the ethical side of things, they need to find a way of cleaning that data before they use it. And in order to do that, then they have to decide in advance, are they going to do it with bodies that already exist that are trying to do it? Are they going to do it in-house with their own teams to do it, and invest in that alongside the actual progression path for the technology and the data itself on the protecting against risk or the adversarial side of things then too. So the best companies will invest in it and choose to do it. It is a difficult one. It is for sure difficult. It's something that should have been built in from day dot. But at the time that we first had a World Wide Web, there wasn't nobody could conceive of the idea that we might have AI that's using all of the data from the World Wide Web as well. So it's a job I don't envy, but it's certainly something that if we're conscious enough about it, we can have aspects of the data that are clean to begin with, and then figure out how to train the rest of the models the same way. I would say no. I'd say it appears like that because everything is coming in with an AI label on it. But the reality is that a lot of existing security teams are either replacing people on their teams with different titles, replacing their titles with different titles and adding AI to it. Because the security, for the most part, it's upskilling. If you've worked in cybersecurity for any length at all, at least every 2 years, you're finding that you need to upskill in some new technology, some new viewpoint, some new type of attack, some new tool that's come out. And this isn't any different when you're talking about security on the AI side of things. It's a case of having your security teams upskill to be able to apply that to the AI side of it. And the majority that companies will be looking at when it comes to AI security is, like, say, about the structural security, so what you're putting to prevent people from accessing and stealing or interfering with the data straight off the bat. So that's traditional security in a sense, down to the actual AI security side of it, where we look at the adversarial testing and the red teaming side of things, which, let's talk about big enterprises to begin with. They all should really have something like that in place already. So it's not a massive jump to move from that to add somebody to that team who is more AI specific, or to add more enablement to that team that allows them to be more AI ready to do things like that. Taking all of that on board, it's easy to assume that we would add more people to it. But if you take the other side of it on board, where the reality is a lot of those repetitive things that people are doing in security teams are getting automated more and more as time goes by. You're actually seeing probably the same size teams, but they're able to look after more things because they're using AI, automation, and the intelligence structures to be able to do more with less as such there. So I can see that would be the case, but even now we see things like what was traditionally a software engineer or software developer being called things like a prompt engineer, where they're still actually writing code and developing, but they're doing it via AI tools and using prompts to do it. It's somebody who has the majority same skill set, but a different label on it as such. At least this is what I'm seeing on the industry side of things. So I'd say it's fair to say that it looks that way, but in the reality of things, no. I would say that there's not pressure to have more people on the team. It's to have different skills on the team. So any company who's not allowing their team to upskill regularly to whatever is new and whatever is happening is going to find they might need to have a new AI team because they haven't prepared for it with the team that they have. But most companies that have a cybersecurity team are usually forward thinking enough to have looked at putting AI enablement in front of those teams by now as well. Yeah, for me, it comes down to, it'll be everybody, but I see it most commonly on the female side of things, is simply to get out of your own way. Like the traditional labels, the traditional skills, all of those things are still valid, and you just need to add some AI flavor to it and take it further. So the assumption that you're not able or not ready to do those things is an assumption only you're making. People that are already in the industry looking for people like you to come into your career don't care about those presumptions you're making about yourself. So get out of your own way and come in and join us all on the cybersec side. Best of luck.